Number of solutions to linear equations, usually pretty simple, but sometimes causes a little confusion. I'll show you what I mean. But just to get an idea, if you remember linear graphs, you can have one solution when the two equations, they intersect one time. That's most of the time what you're going to see. Infinite solutions is when you have two lines on top of each other, and this happens when they're the exact same equation. When they're exactly the same. It's just why they would be the same graph and be on top of each other in the first place. So then no solution, they never intersect. So they're going to have like the same slope, and you'll see what's going to cause that there. We haven't even gone into slope yet, but they would have the same slope, but they're never going to intersect. They have a different y-intercept. So they're a different equation, but the variables are going to cancel out is what you're going to see. So let's take a look at this. Number of solutions. Our objective is to determine the number of solutions if the variables cancel out. So if the variables don't cancel out, then you just simply put one solution, because that's what you're going to get. But if the variables cancel out, that's when we run into issues. So that's kind of the key thing, when the variables cancel out. So let's look at this. Distribute the 14z. Well, let me rewrite it first. So I'm going to distribute 14 first. So I'll get 14z plus 42 equals 14z plus 21. So what do we normally do? I normally like to move the variable over to the right side. So I'm going to subtract the 14z to the left side. And that's what you notice. This is kind of an indicator, and you're going to see this pattern as you do these problems. Look for the pattern. It's going to help you in the next assignment. So I can already tell from the start of the problem that these 14z's are going to cancel out. And that's where the confusion happens a lot of times, that people think, okay, do I put 1z? Do I put 0z? So yeah, it's technically 0z, so the z is just going to go away. So 14z minus 14z just goes away, and you're left with 42 equals 21. Now, is this a true statement or a false statement? So this is a false statement, so 42 does not equal 21, so this would be no solution. So it's not the exact same equation. If this was a 21, they canceled out, then 21 equals 21, it's a true statement, and that's when we were saying earlier, you're going to have that same equation twice, so it's really just going to be on top of each other like that. All right, let's look at this one. So we have negative 4x minus 7 plus 10x equals negative 7 plus 6x. So let's combine like terms. Negative 4x plus 10x is 6x minus 7 equals negative 7 plus 6x. And this is where I was talking about. From already you can see 6x and 6x, those are the same thing. So if I go ahead and subtract the 6x, it's going to cancel out. And we're left with negative 7 equals negative 7. Now that's a true statement, so this is infinite solutions. We have an infinite number of solutions, and that's what we would see, is that they have that same slope that the variable cancels out. Now the other situation you run into is like this one, and I'll go through it quick. You get 3x plus 15 if you distribute equals negative 4x plus 8. Realize that these are different. So if I add the 4x, I'll get 7x plus 15 equals 8. And you just continue this problem out, and what you'll realize is that you get a solution at the end. So since we got a solution at the end, we would say that this is one solution. Or since we're writing it now, I should probably write out 1. So what's the main idea? And notice right there, this was the same exact equation. So the main idea that we could take away from this, if the variables cancel and you get a true statement, like 7 equals 7, then you have infinite solutions. If you get a false statement, so for example, like 7 equals 4, you get no solution. If you get an answer like x equals 7, then you have one solution.